plus 2.1 raised to 3 raised to power 1 by 4. So, f of x y x cube plus y cube raised to power 1 by 4, where function f is a function of x and y. X is equal to 1.9 from the data. We take first variable as a 1.9 and the second variable is 2.1. So, here we converted 2 plus 2 minus 0.1. So, x0 is equal to 2 and delta x is equal to minus 0.1. Therefore, x0 is equal to 2 and delta x is equal to minus 0.1. Similarly, second value y is equal to 2.1 raised to power 3. This will be 2 plus 0.1, that is y0 plus delta y. So, value of y0 is equal to 2 and delta y is equal to 0.1. In this method we can also choose any other value. Here if we take 2 minus 0.1 or if we take 2 plus 0.1, but we take those value of x0 and y0 for which function value directly possible without any calculator. Okay. So, if we take x0 is 2 and if we take y0 is also 2, then it will be 8 plus 8 raised to power 1 by 4, 16 raised to 1 by 4, that will be 2, means we choose those values of x0 and y0 for which value of the function directly possible. As function is x cube plus y cube raised to power 1 by 4, delta f 1 by 4 x cube plus y cube raised to power minus 3 by 4 into derivative of x cube, that is 3x square. We find the value at the point 2 2. So, x replaced by 2, y replaced by 2 into multiply by 12. So, this is 16 raised to minus 3 by 4, answer is 3 by 8. Similarly, if we find out derivative with respect to y, here y is there, 1 by 4 x cube plus y cube raised to power minus 3 by 4 into 3 by square. So, if you find the value at the y del f by del y 2 2, that is equal to 3 by 8 as a function of same variable. So, derivative at the same point, that is why answer of del f by del x and del f by del y both are equal. So, change in f, that is delta f by del x into delta x plus del f by del y into delta y, 3 by 8 into minus 0.1, as we seen here earlier, delta x is minus 0.1 and delta y is 0.1. So, answer of this 0, means there is no change according to these two values. So, approximation value f of 2 2 plus delta f, that is equal to exact value of f of 2 2, that is 2. We take one more example. Find 1.04 raised to power 3.01. If a 1 raised to 3 is there, then it is possible. Calculate directly 4 raised to 3, 3 raised to 4, but here base value is also 1.04 rational number, as well as power is also rational number. So, we take f of x y is equal to x raised to y, where f is a function of x and y. We take x as a base value and y as a power value. So, base value in the data is given 1.04 and power value it is given 3.01. So, according to 1.04 we converted into x0 plus delta x, means x0 is equal to 1 and delta x it is 0.04. So, x0 is equal to 1 and delta x 0.04. Similarly, power value is 3.01, we take it is equal to y. So, that will be 3 plus 0.01, that is y0 plus delta y, means value of y0 is 3 and value of delta y is 0.01. Now, in this case, first of all we find the function value at the starting point. We take x0 is equal to 1 and y0 is equal to 3. So, if we find the function value at the point x0 y0, f of 1 3, as value of x is 1 and value of y is 3, that is why 1 raised to 3 by the function, that is equal to 1. So, function value at the point 1 3 is 1. Now, we find the change in f. F is a given x raised to y, means a function of x and y. We take derivative with respect to x first, means y is a constant because we take partial derivative. So, derivative of x raised to y with respect to x, that is y into x raised to y minus 1. Now, we put the value x is equal to 1 and y is equal to 3 So, this is equal to 3 into 1 square, that will be 3. Now, we take derivative with respect to y. Here we take partial derivative with respect to y. So, base value x as a constant, that is why derivative of x raised to y with respect to y, that is x raised to y into log x. We find the value at the point 1 3, that is log 1, because 1 raised to 3 is already 1 and log 1 is 0. So, change in f is equal to del f by del x into delta x plus del f by del y into delta y. Del f by del x we find earlier, that is 3, and del f by del y, that is 0, and change in a delta x is 0.04 and delta y is 0.1. So, this is equal to 0.12. So, approximation value, that is f of 1 3 plus delta f, change is 0.12 and the value is 1. So, final answer 1.12. So, this is the value of 1.04 raised to power 3.01. One more example, 1.53 raised to power 4.27. So, x raised to y, f is a function of x and y, x, that is 1.53, we converted into 1 plus 0.53, means x 0 is equal to 1 and delta x is equal to 0.53. Power y, that is 4.27. So, this is equal to 4 plus 0.27, y 0 plus delta y. So, y 0 is equal to 4 and delta y is equal to 0.27. So, here we take x 0 is equal to 1 and y 0 is equal to 4. So, function value f of x y at the starting point x 0 y 0, that is f of 1 4 is equal to 1 raised to 4, that is equal to 1. Now, function of x and y, we take derivative, again we see that derivative with respect to x partially, that is y x raised to y minus 1, and value at the point 1 4 is 4 again. We find out derivative of f with respect to y partially, that is x raised to y log x, and we find the value at the point 1 4, that is log 1, again 0. So, delta f is equal to del f by del x into delta x plus del f by del y into delta y, because f is a function of x and y. Del f by del x is 4 and delta x change in x is 0.53 plus change in y 0 into delta y is 0.27. So, final answer 2.12. So, this is the change in f. So, approximation value is equal to f of 1 4 plus delta f. We have already value of f of 1 4, that is 1, and we find the change in f, that is 2.12. So, final answer 3.12. So, according to this method, we discuss about how to find out approximation value and how to find out any value. For example, how to find out this type of value 1.53 raised to power 4.27. Okay. So, in this formula we can also find the approximation value as well as also find the change in the any variable with respect to another two variable. Thank you.